Okay, today we're going to work on getting our hero to walk around in our game in a very simple manner for now, just so that the controls operate the character the way we want. Later we're going to use a more complicated rig, the kid character that we were making before. For now I'm going to use a very simple character and rig just to make sure that everything's going to work fine. So I got this guy here. He's a singular solid mesh, and I took all the unused bone nubs off just because it's a little more efficient. I don't think it'll affect the export. I left these on the stack. I don't think these will affect the export, but anything above the skin modifier is not going to be exported or imported into the game. To get the flex in there, I use a different trick, but we're not going to get into that. All right, we'll just make sure our model is set up to work the way it should. So first of all, we'll check. We've got a root bone right here, pelvis. And if we double click it, all the bones show up, which is good. And we don't got any unused end nubs. Not that it really matters. Like I said, we got a singular mesh here. There's no weird rigging or anything complex that could confuse the exporter or importer. So this simple rig should work very well. First, grab the root bone, and I don't think it matters if we double click and get all of them or if we just grab the root bone. In some circumstances you might actually have to double click to get everything because of the way the hierarchy works, but in this circumstance I think you can get away with just grabbing the root bone, holding control, and grabbing the mesh. Now if you're having trouble with that, you can go over here, and I'm not sure if you have these options in other 3D programs, but you can go to bone select only and then go to geometry, and then that way you don't grab any of the control shapes if you're using control shapes, and then you just control and drag over top and select your meshes. In this case it's one solid mesh. Okay, so we're going to go to export selected, and I'm just going to call it stuffy. Alright, so for export options, I'm pretty sure it doesn't need to be triangulated, but we'll leave triangulate checked just in case. And that means that none of the polygons are going to be stored as 4-point quads, they'll be stored as actual triangles. You can set up your own importer too to set up insurance of triangulation for you too, but we'll get into that later. Got this checked off, not sure if that's important, but I'm leaving this checked on. We don't need smoothing groups, we don't want smoothing groups even. We prefer all the normals to be smoothed out and averaged, so we're not splitting per vertex normals. In this case we don't need normal mapping, so I'm just leaving this unchecked. If you did, you might want that checked, or you could generate them when you load up, but since we're using the skin meshed from monogame, then we're not going to do it that way. See, we don't need any of these. Animation, make sure it's checked. Make sure to bake animation, so it bakes out the rotation, translation, and scale for all of the important keyframes. So there'll be 100 keyframes here. I'm going to bring this down to 99 because 0 counts as a keyframe also, so that'll give us 100 keyframes. 0 and 100 are the same. We don't want it to duplicate it. I don't think we need to use resample all. I don't know what difference that makes actually. And for deformations, I just have skin. We're not doing morph targets in this. All this other stuff, I make sure it's unchecked. We don't want to export lights and cameras and stuff, not in this situation. I select automatic for units, and it'll pick the appropriate units based on what your setup is. For axis, it might be on Z right now. You might want to make sure that you put it on Y. For texture loading purposes, I prefer to keep it on ASCII, and I'm using the 2012 format. So if it's ASCII, that means it's letters instead of binary, and you can go through the file and you can edit certain things. And in this case, I want to edit the paths for the textures so that I don't have to set up a relative texture path for the game. I can just make whatever path I want. So hit OK. And it says here, modifiers listed above the skin. We're not worried about that. That's what we expected. So it exported OK. So this is what we expect to see when we import that animated mesh. Now let's go over to the walk animation. We'll do the same thing, and then we'll do the same to the run animation. I would note that if you have extra objects in your scene and you're parenting the object directly to a bone, if you're parenting the object directly to the bone, I don't think it's going to work right. Not in this style of the skin mesh, doesn't import correctly. So what I would do in that case, if you wanted to keep it, that extra model piece, is actually make a bone that say comes down from here, and then one that goes out to this eye and one that goes out to this eye. Just make an extra string of bones basically to set up your eyes, and have the eyes give a skin modifier to the eye. Actually in this case I think I did that, and I added the head bone and just made it so it's 100% influenced. So that's one option you can do if you want to do it that way. In this case, for now, I just want to make sure I keep things simple. I'm just going to hide these, hide selected. So just for debugging purposes, we'll take things with baby steps and make sure the simple stuff works first and work our way up to more complicated things later. Now you might be wondering why I don't combine all the animations into a single timeline and then export them that way. You can, and then play from a certain point or use a certain take number. I've been told that it's actually preferable to just export your individual animations. You can correct me if I'm wrong in the comments, but the reason I was given for doing that is you could have a really big project with a lot of different animations and you may need to swap out a whole bunch of different animations. And if you keep modifying animations and you have to rebuild the file each time and convert the file and all that, it takes a lot of extra time. And if they're individual files, it's just a bit quicker to develop it. If everything is good at the end, perhaps you could do something where everything gets put into one big file. There's also the possibility too that you might not need all of the animations for every area that your character's in, depending on what the character needs to do. So it just depends on your needs. So this is the way we'll do it for now. Again, make sure it's the root bone. Go to bone select only, double click it to grab them all, or just the root, and it should export everything else too. It might not, but it should. Then go geometry, control drag and select it all, and export selected. So maybe I'll rename this one to Stuffy Idle, and we'll call this one Stuffy Walk. Let's make sure that the number of frames is exactly the same as the other one so we can do interpolations, blend the animations together. So we can make him slowly go from idle into a walk as he picks up speed. And I'm just going to do the same thing for run. Back in a second. You may notice in my case my run speed for my characters seems a little on the slow side. When I was editing it, actually I had it at 2 times speed, and we may make it even faster than that. But put it down to 1 times again. We'll be controlling the playback speed to match up with the character's motion, how fast the character runs. And the reason why it seems so slow is because there's 100 frames. We've got to make sure that there's the same number of frames on each export. Again, this will be 0 to 99. Later on, if I find time, I'd actually like to show how to export something more complex like this. At the current time of making this, the SkinMesh importer won't accept this particular model. Not entirely sure. It's something to do with the hierarchy, I think. And I think it may have something to do with some of these dependencies here with these shapes. They're not directly parented, or at least I don't think any of them are directly parented to the skeleton. They're constrained to the skeleton, so I don't think it would be an issue. However, I'm not entirely sure if that's the case. But either way, what I want to do is create a unique importer for this particular model so that it'll be able to accept the FBX file for it, no matter how complicated the rig. So where we left off before in our previous 3D tutorial, if you go to the top in your Game 1 class, we'll add a new model. We'll call it Stuffy Idle. Okay, let's go into the content directory here, and I added this here folder called Stuffy, and I moved a copy of the animations into there, and the texture that goes with it in here as well. Because I don't have it embedded, and I'm not actually 100% sure if the embed load works right now. It probably does, but just in case, I put it in here. So I'm going to open with Notepad, and I was going to do a Control F find PNG, and the first PNG you come across, you're going to want to take this starting one here and go all the way to the beginning. Hit Control H, tab to the next column, or the next entry here, and just make it empty, and then hit Replace All. That step I'm not sure if it's that important, but you'll want to do that for all the... There'll probably be a couple of them like that where you have to. Just depends on if you have more than one source folder. So if in this case I only have one source folder, so I just have to do it with these two. Here I select from these 2 dots all the way to just before the name of the actual file. But this time I want to put ... and then Stuffy, because that's the name of the folder it's going into, and then another /. Make sure you have both backslashes. Hit Replace All. So as long as our root directory is set to content, it'll look in Stuffy and get the PNG. If you change folders, you'll need to change this file. Okay, so let's save this one, and let's do the same thing to the other 3 files. Keep in mind you don't have to worry about these ones up here, the FBX stuff, just the PNG. So Control F, PNG, highlight it. When you go to hit Control H, it should automatically be up there. Just make this blank again. Hit Replace All. Now, actually, before we do that, let's undo that. I'll show you a trick. If you go up to the top here, there's the Start Recording. Click on that Start Recording in your Notepad++. Then select Control C, Control H, Replace All, and close. Go to where this dot dot is, Control H, and we'll go Replace All, except this time dot dot slash. We don't need content because we're going to specify that as the root directory. So we're just going to put stuffy, or whatever the name of your folder is, and then hit Replace All. So what we just did there, next time if we need to make changes to this file, we can just hit play and it'll make the same changes. Let's save this one. We can't use playback on this file because this one's a bit different. But if we needed to make changes to the other one, we'd be able to do that. This editing and stuff seems like it might be a bit of a nuisance, but in the future we're going to probably be working on, I say in the future, but I don't know when because I don't know when I'll have free time, but we'll be working on making an FBX importer of our own, and it'll bring all the necessary files in where it needs it. We might even set it up also to import embedded textures. If all your PNG files look okay, you can save. So I just added this extra code here in the Game 1 class to what we've been working on before. Instead of just doing a single model here, I'm going to do an array so I can have the 3 animation models. We're going to need our animation player and bone transforms. In order for it to know what the animation player is, I already did this, but I'll show you what I did. We have to go up into references and we have to right click, add reference, and use the browse button. If you don't have the monogame version made, you can probably find the SkinMesh project on the internet, download it, and build the projects. You'll end up getting these DLLs. So I added the SkinMesh DLLs folder to the project and added these DLLs into this new SkinMesh DLL folder. And for references, just make sure that you have browsed to that one and added it. And then go into content. There's a couple changes you need to make so that these will work in here. Oh yes, and make sure you go add existing or create a new folder and then add existing to that folder to create the folder with the new stuffy FBX files in it, as well as that texture. But before you even select those, select content and go down to the bottom. And I already did this, but this is what you'll need to do. Click on references and click add and navigate to your SkinMesh folder and add the pipeline one on the top there. And then click OK. On each of these FBX ones, you'll have to make sure you remember to do this for every FBX you put in here that happens to be a SkinMesh. I'm using FBX importer. Change this model processor to SkinMesh model processor. This default effect should change to skinned effect after you do that. Okay, and I don't think we need to do anything else in here. And then just go to the next one. Make sure you make those same changes. Model processor, SkinMesh model processor. Make sure it's on skinned effect. And then just do that for the last one and then hit save. Now, again, before you try to compile these, there's one more change that we need to make to these FBX files. So we can go right click on it and click open with, and go into Notepad++. So for this step, it's going to depend on how your particular model ended up exporting. But what I would do is, to make sure it's going to work, hit Control F, and you're going to look for a geometry section. So any of your geometry for your character, you should only have one mesh, ideally. And so I would write down the name of the geometry or the mesh's actual name, do Control F, and then look for that name. So in my case, the character is just called body for the geometry. So I'm going to look for body and hit enter. First one that comes up, not really interested in. That doesn't have any curve nodes. So we're looking for those curve nodes. Hit enter again. Then you get to a spot that says connections. You'll see body root node. So this part we don't care about. We're going to hit enter again. We get to material and then we get to geometry. Geometry is what you're looking for. You see geometry and the name of your character and this sort of thing here. Then you're at the right spot. So right after that, look to see if there's any animation curve nodes here. These can't be here for it to convert properly. So just going to delete those and make sure you don't, make sure you're deleting the right thing there. So again, as long as it's these particular animation curve nodes after the geometry and the name of the geometry that matches your character's geometry. Don't delete this part here. just these animation curve nodes for translation, rotation, and scaling. Okay, and that's all you need to do. So just make sure you save it. And once you've done that to all 3 of the files, or however many files you have, and you're sure you got all your textures in the same folder, and you've made the right changes to the relative file paths, you can save, you can build, and just keep in mind that you don't have to rebuild all. You don't have to just hit build each time, because some of these files are going to take a long time. So only the ones that you've changed or updated or modified or added, you can just click on it and click rebuild. So if you get 1 succeeded, 1 failed, or 0 succeeded, 1 failed, but you still got a check mark, on rare occasion that can kind of mess things up, and you may have to fix whatever is going wrong with that and exclude from the project, re-add it, and then change it to skin the model processor again. So I think what happens there is that for some reason, this only happened to me once before, it's never happened to me since, but it thought that for some reason that the file's built and it's fine, and it's not trying to rebuild it when I make changes to it. But like I said, that only happened to me one time. Maybe it was just a fluke. It's never done it again. Just thought I'd mention that. So now that we got those working, and those are in XMB format in the executable directory. So what I did here is, instead of using enumerator, which we could do, but we'd have to use a cast on it, I just used constant integer, idle equals 0, walk equals 1, run equals 2. And that's just for clarity purposes, so we know exactly what each index represents. So we now have an array of matrices for idle transforms, walk transforms, run transforms, and another one for blending those together. So depending on how fast he's running, he may be between these 2 animations or somewhere between these 2 animations. This can be applied to other things too, for transitioning into different attacks or poses or whatever. I think in this case, most of the character actions will be fast enough that animation blending won't be necessary. But for idle to run, I like to have smooth analog control, so I like to have the 3 transitions like that. It actually might be a good idea to do a blend to a jump too, but that might get to be a bit complicated because you could be between these 2 and then have to blend again to blend into the jump animation, so I wouldn't actually advise that. Alright, so animation player, I got the idle animation player, I got a walk animation player, and I got a run animation player. Each one's going to hold on to a different animation clip because I don't have multiple clips in one. We're going to need a hero position. I'm starting the character out at 0, -1, and 0. So it'll be slightly above the surface of the ground. He'll have a velocity, and the reason I added this last non-zero velocity, this is because we can keep track of the velocity if it's not 0. And then if we reach a point during our frame loop where the velocity is 0, but we need to know what direction the character should be pointed, we can refer to the last time it wasn't 0 to figure out what angle the character should be facing. The velocity also represents the direction of the character, and that's where we get this hero angle from. The hero angle is calculated from the velocity vector to figure out which way the character should be rotated so we know which way he's facing. The play speed plays the animation speed. That's going to be determined by how much you push on the analog stick, or joystick depending, or how much you've accelerated using the keys on the keyboard. Speed is more or less the magnitude of the velocity, so how big that vector is, and the speed can be used to determine other things, such as the play speed. The hero height, we use that for factoring in how far above the ground we should place the character. So if we have the character following the terrain, and we're using the top of the terrain itself as a guide, we can just say that if the character's not jumping, if the character tries to pass through the ground, we can set the character's position at the ground height at that location minus the hero height. And then that way the character is always above the ground, walking right on the ground. We'd also have something like is jumping, like a Boolean for is jumping. And so if he hits the ground or, falls off a cliff or something, is jumping would change to false because he's in the air. Or it would change to true, actually, because he's in the air. Or you could have an in the air Boolean or something like that. And then you change that to true if he tries to pass through the ground or some object that's underneath him. This ground Y here, we can pass that around throughout this class and use it for determining whether an enemy is on the ground, how close to the ground something is. That's just what that's for. It might be something we use later. We might use another collision system, so it just depends. But for now, we're going to use this. And this matrix here is used to create our rotation matrix for our hero, which is calculated from the hero angle. and then that's factored in when we go to draw the model. So I'll show you that in a bit. I don't know if I showed this before, but I added this song here. And in the load, we're going to load up a song. So before, we also used to have this basic object or basic 3D thing here for defining our own little basic objects like floor, cube, or whatever, which we can use to build certain things into our scene, like destructible objects or whatever. For now, in this tutorial, I'm not going to use those, so I'm just going to comment that out. Let's put it in this model section here, maybe. Alright, and since we're not using that, let's just comment that out down here in init 3D. Let's put it over here. Let's add our hero models. So that'll be a new model. Oops, model. And we got to allocate for 3 of them. We'll also set our last non-zero to something so that has some kind of non-zero value to begin with. So that's the last velocity the character is facing. And I believe the character is facing towards the camera when we load it. And we'll just define the hero height here. Might even want to make it a constant or something, I don't know. Although I guess you might be able to load and switch characters, so might also want to leave it open. Okay, let's go down to load. And again, we're not really using these, so comment that out. Usually it's suggested that if you're going to comment something out to get rid of it completely, but we might bring these back, so let's put this on the bottom then. So we get the sky, landscape, and for now, because we're going to be loading a bunch of stuff from one folder, let's go content root directory equals to content, and we're going to go into the stuffy directory or whatever you named your directory. And so for hero idle, which is index 0, we use content.load using model, and make sure you get the capital letters and small case letters all correct, and it's exactly the right file name. And I'm just going to paste this twice, change this to walk, change this one to run, and then over here I'm just going to change this to walk, change this one to run. Now let's change the content root directory back to what it was, so we don't get messed up. We'll need to look up the skin data. So for this, we'll need skinning data equals, and we'll say skinning data idle. Change this to a small letter. We'll say equals hero idle dot tag as skinning data. So that's going to hold our skinning. Wait, this shouldn't be equals here. Okay, that's going to hold our skinning information. Let's just make sure it's good. So we'll say if it's null, throw new invalid operation exception. Doesn't know what I'm talking about. So let's right click on here using system. Say this model does not contain skinning data tag. Alright, now let's set up our idle animation player. There's a new animation player, and that is what we had in this skin model thing over here. And we're going to be using our skinning data for idle. And we'll do the same thing for walk and for run. And just make sure that you go over all of these carefully to make sure you got that as walk, that is walk, this is walk, this is walk, and this is walk. And then do the same thing for run. Okay, so I added the run, and I thought while I'm at it, I'll add the music. So I use a song called Forest Shadows, which is borrowed from a game. I can't remember which game. I think it might be Xenogears. I can't remember for sure. And I set the media volume to half and start playing it. Okay, and then I realized we also need to set up our transforms. So first of all, let's get the bones count, and we'll just use what's in idle because they're all going to be the same. Bones.count. So we'll start with our idle transforms. It's going to be a new matrix, and we'll use that bones count. Okay, I just added this run, this walk, this run, and also added this blend transforms here. We're going to use that to blend between idle and walk, or between walk and run, depending on how fast the character is going. Okay, so let's add a way to copy the final transforms. So we'll go idle and copy in the absolute transforms from idle transforms. So now hero idle contains all the matrices that we're going to need for the transformation process of the character to animate it properly. Okay, I just did the same thing for walk and run, making sure that this says walk and run as well. Alright, let's start an animation. We're going to need to run all three at the same time so that they're always staying synchronized. Animation clip. And we can get away with this with the main character because I mean, it would be a bit different, it would be a bit inefficient if we tried to run all kinds of different animations for blending for all kinds of different characters. And in this case, it's definitely not going to be anything I'm going to be worried about. So we're going to get the clip, the animation clip, using the skinning data idle and its animation clips. By default, it should be called capital T, take 001, depending on how it's exported. I think by default the FBXs are going to export your animation clip as take 001. You can check off a box to have it exported based on the name of the scene. So if you know that that's the case, then you would have to change that. And it could be a different animation, in which case it would be a different take. In this case, we're doing our animation clips in separate files, just in case we need to make a whole bunch of changes. Changes to walk and this one to run, and these are also taking from 001 in each file. Okay, and so now that we got references to those clips, let's tell our animation players to play those clips. Start clip, idle clip, and we'll do the same thing for walk and run. Okay, so let's go down to update, and here we update the input, check to see if we're trying to get out of the program, and we got this camera section here. So I'm just going to say camera and update the player cam. So we're going to want to change this so we can pass in the hero's position and actually have a look at the hero. And let's put some of this camera control into the camera class itself. Since this basic 3D stuff is no longer being used, we could even just delete it. So I mean, these were just for examples, but yeah, that was just for example. We'll delete that. So I think when I was showing this tutorial before, I had this as left, right, up, down, AZ. Changed it to up, down, left, right, page up, page down, just because it seemed to make more sense to me. Like I said, since we're not using this object 3D thing here, what we could do is we could say that this is the player position that we're going to move. But I'd like to accelerate the player, so we'll change the player's velocity instead. So here we could go hero velocity plus equals, and then we're going to want to change the hero's velocity relative to which way the camera's facing. So I think the only place we're not going to do that is maybe for the page up, page down, or we can just manually set the height of the player. And I would probably only use that for testing purposes. We'll just use it for testing purposes temporarily. So minus equals 0.05 should be enough in one frame, enough acceleration to notice. So this one will be the same, except it'll be plus. Oops, what am I doing here? Yeah, this one will be the same, except it'll be plus equals 0.05. If the character's going left, we want him to actually go left. So let's use the camera's left. We'll have to create a new vector though, because we don't want to use the cameras up and down, or we don't want to use the pitch of the camera, because then otherwise the character will go up and down, and we don't want that. So we'll use the cam.view left, so the camera's viewing matrix, or yeah, the camera's view, and we're going to get its left and X value for this one. Camera's view, left view, or left direction. So that's left of the camera. And our camera is pointed right at the player, so the player will move exactly left from the camera's viewing direction. I probably said multiple times now. Now this is going to be easy, we just have to copy this concept. It's like a lot of these things, you can just copy the concept all the way down. Oops, what did I do there? Just double click left and type right. And same for the next one, for the Z one. Wait, I got up down over here now. Let's change this back to the left. Change this back to right. Because I was thinking, I actually usually do this as left, right, up, down. So I was thinking in those terms. Sorry if that messed you up. And we're going to go up, down. So hopefully this makes a lot more sense now. Alright, so for up, we want him to go outward. So let's make that vector into the forward vector of the camera. Forward. The reason I'm multiplying by 0.1 on the ends of these is because we want to accelerate them by that much. So this just gets the direction of the vector, and the 0.1 is the magnitude of the velocity that we want to add to the current velocity, so how much acceleration we want to add. And this will be our backward. Okay, and that changes the player speed. Now, let's also make it so we can adjust the player speed using the Gamepad controller. This probably should be something done in the input class, but I'm just going to do it here. I don't know, maybe it actually shouldn't be done in the input class. There's no point in having your code all over the place and not being able to find out where it is. So let's go move, I'll call this move pad left right. So we're going to capture the value of the left right amount, and let's make another one. Move pad down. Let's set those to 0. This one can be 0 to start with, and that's in part because, like, let's say the gamepad was disconnected and then plugged in or whatever, or there's no key presses. You want to make sure that these are zeroed out each round. In which case, I don't think these should be in here. They should be out here. So let's get the left-right direction. So say move pad left right is equal to input of gamepad GP thumbsticks, and we want to check the left thumbstick. It's not the left direction, but the left thumbstick. And we also want the Y direction for the up down. I'm having a hard time typing because my fingers are really cold. Let's go to input, and up at the top here, let's add our public constant float dead zone. We're probably going to use this in more than one place. We might even have like a player class or a 2-player mode or whatever. Depends on what we plan on adding. So this is the dead zone for analog. And we'll save that and just close it for now. Okay, back in game 1, let's say if the move pad's up and down is less than negative of inputs dead zone, or greater than, up down's greater than dead zone, or the left right's less than negative dead zone, or the left right's greater than positive dead zone. Fast forward. All right, now let's go ahead and just say that the hero's velocity dot x is going to be equal to move pad left right times cam. We're using the cam view direction again, and it's x value. And we're going to add to it the move pad up down value times the cam view forward dot x. So the x amount for each vector is added on, depending on how much x we're getting out of each vector for that camera, or those camera directions, forward and right. Let's copy this and paste it here. Change this to Z, and we'll change this to Z, so we're just getting the Z component this time. Oops, I must have deleted a curly bracket. All right, let's go down, and let's do some collision with the ground checks. I'll just say collide with the low ground, because there could be multiple levels. It could be a section 2 for colliding with stuff that's on top of the ground. You always want to make sure, though, that your player doesn't fall through the ground, because they're going to fall forever. So you need something really robust to make sure that they never actually fall into the ground or get stuck in the ground. Okay, so I just added this, and for now, all we're going to do is we're going to check to see if it's less than the ground Y, but later we're going to call, or later what I would suggest is to set up something that gets the ground using the hero position's XZ coordinate on the map. It gets where the player would be if the player was on the ground. And so if the player's current position, Y position, is less than ground Y, is that correct? You know what, just to make this more fun, let's change, instead of this page up, page down, let's just go ahead and make this space. And let's make it fairly quick, and we won't need the down. We might use that for ducking or something later. Oh, I just realized this is going to be a bug. This should be minus hero height, and the reason is if we just went ground Y, this would always be true and it would always be changing it to 0. So we're just making adjustments to velocity here. Now let's make it so the hero actually falls. Hero position dot, or hero vel velocity dot y plus equals, I'm gonna guess for now, 0.05f. Okay, so I just paused it there for a second, changed my color theme just for the heck of it. I did some exercise too, that's why I'm a little bit out of breath. Oh, this isn't right. Should be greater than ground Y. Let's see. And on second thought, we'll make this up here. Let's make it so that if the user, let's make a boolean here for jump press so we can have different options for it. Eventually I'd put these into their own, maybe even into the input class or a player class or something, so the player can customize their controls. So if jump pressed, input key down, and we'll go keys space. Now I'm going to say or imp.gamepad is button down, and we're going to go with buttons A. So now here I can just say if jump was pressed. So push the jump button, whether it's on the keyboard, on the mouse, on the gamepad, whatever you want, and whatever key you want that to be. Alright, so I'm going to say minus 1.3, and let's make a boolean called on ground, and we're going to say false. So that way we know whether or not we're on the ground, whether or not this jump is actually going to work. So if we're not on the ground, and we can't push jump button, well, we can push it. We can push the button, do something else, like a double jump. Just depends on what you're doing. Well, I'll add that logic later maybe. Let's go up to the top here. So stuff pertaining to the hero, eventually it's all going to get moved into like a hero class or something. Or actually like a character or an actor class, because you can actually set up some AI that drive their own controls as though they're pushing a jump button or pushing left or right or whatever. And the AI is actually the one that's triggering the button presses and just running the exact same logic as it would for a normal character. You can change the jump height, how fast they can run and all that. So, and have them talk to each other and make decisions on whether they should run away or toward objects. After this, let's add that boolean on ground. And you know what? I realize I'm getting carried away here. We haven't even tested these out yet. So let's make sure at least the first one is actually going to load in here without any issues. I'm just going to comment out anything that's not idle for now. Just going to do this, because we want to make sure that at least the idle is going to work. And then we can test out the walk after that and the run after that. Let's also make so our camera class can take the position of the character in here. So I'll say vector3, and I'll just put hero pose. Yes, hero pose. It's not going to do anything with it yet. We're going to make it so that the camera targets the hero. Okay, let's go down to the bottom of the update class again. So if you remember at the top here we had this playspeed thing, and we're going to get the length of the hero velocity and use that to get the speed, and then multiply that by some value to get our playspeed for the animation, depending on how we need to adjust it. Okay, so back down and update, added this here. So I'm going to take a speed amount, multiply by 6, and add 0.5 for the minimum speed, basing that off of previous trial and errors. So I tried this once before already. I already know that I'm going to need speed times 6 plus 0.5. Right now we're just going to set it to 1 and multiply that by the elapsed game time total seconds. We'll use that elapsed time, pass it into the idle animation update, and then because we're modifying the time, it's going to change the play speed based on that. So that's how we can control the play speed. Boy, I note too that this is right here. You can see it's relative to current time, and it's possible to change the root transform, so where the player's root bone is going to start in the world. But we're going to do this a different way down here where we render it. Go down a bit, we get to that set 3D states that we had before. I'm just going to make this into a region and make it look pretty. This way it's nice and handy because we can just close stuff we don't need to see when we're working on stuff, so it's less of a distraction. Right here I'm going to add a rasterizer state. Counterclockwise, new rasterize state, and we're going to say fill mode is equal to fill mode dot solid. This should be a comma because we're providing information as to what we want members to be. So call mode dot counterclock face and semicolon on the end. I'll say non-pre-multiplied, and we'll make that one default. And if this is null, we can just do this now. We can just say GPU rasterizer state is equal to rs underscore ccw. GPU in this case, as you might remember, we already defined that to be the graphics device. Alright, so now down in draw, we're not drawing these basic objects right now, so I'll just put that there, maybe shove it off to the side a bit. And this thing right here just takes everything that we're drawing and stretches it out to the desktop. So that way we can design our game for any resolution we like, any specific resolution, and no matter what the desktop resolution is, it'll work good. Alright, so right here, after we draw the land, let's add idle anim player.get. I want the skin transforms, and we'll put them into this bones 1 thing. Okay, so let's go down to draw model and just borrow some of this. Yeah, let's borrow this whole thing and modify it. Go up to here. So for each mesh in, this time it's going to be hero, say idle. And it doesn't really matter which one, they got the same number of meshes. And we'll make this into skinned effect in mesh.effects. And because we're going to add a shadow, let's make sure we add a reset on the alpha, so that it's not see-through at all. Gonna enable default lighting. To make it smooth, I'll say per pixel lighting is true. Texture enabled, I think is true by default. I'm pretty sure. I can just probably remove that. View is the camera view. Projections, the projection matrix. We can actually use the material colors to set these values if we wanted to. We're not going to worry about fog for the character because the character will always be close enough that the fog won't really affect the character. So I'll just take that off. I'm going to probably do something with the specular though. Specular color. And your brightness of your specular is kind of determined by the specular color. So if you had like a brightness factor and a color, you could actually multiply it by the color rate in here before it even sends it to the card. I'm going to keep it somewhat low here. So kind of have the greenish light turned up a bit, a little reddish. And then this specular power is kind of like the glossiness factor. It's kind of how narrow that reflective shine is going to be, or how spread out it is. So if I said it was like 4, it'd be really spread out. And if I say it's 128, I think that might be the maximum. I'm not sure how high you can go actually. But 128 is pretty high, it'll be pretty narrow. This should not be specular color, this should be specular power. So I took the ambient, which is the minimal amount of light. It takes the darkest, like the black color, and adds a tiny bit of light to it. So the minimal amount of light you're allowed to have. The diffuse is basically the material color if there wasn't a texture applied to it. Depending on the shader, you may want to make sure those are in there, otherwise it might not show up right. In this case, I think we're going to be okay. Let's make sure we include a world transform. So I just moved that up to here. Alright, so the first transformation we're going to need here be the bones 1 mesh parent bone dot index. So for this mesh, it's going to get the parent and use the transform of the parent to determine the world transformation for this. And then we're going to go times matrix hero rotate times matrix create translation. The translation is what actually moves the hero into position. You want to use the translation last. And if you had any scaling, you could put the scaling in front here too. Let's go back up, calculate the angle of the hero from the velocity vector, and that way you can use that angle to get the rotation matrix here that rotates this skin mesh player. So let's go back up here. Okay, so back up and update. I'm just going to disable this code for now using the comment out. I just want to make sure everything's working right before we proceed. Let's update the hero position. Plus equals hero velocity. And I think for the hero velocity dot x, let's slow it down a little bit each frame. So we'll leave it at 96% of its current velocity, and each frame it'll be 96% of its next velocity, so it'll slowly go down. We'll have to do that to the z, but we don't want to do that to the y because jumping velocity is kind of its own velocity vector. Let's make a vector 2 for a map velocity, and we'll assign it to this hero velocity.x and hero velocity.z. So the y is actually going to hold on to the z. We just need 2 floats to store it in. And then this way, it just makes it a bit easier because I don't really want the velocity with the y velocity factored in, because I want to limit the ground directional velocity in a different way than the gravity or jumping velocity. So we'll set the speed, which is sort of the ground motion speed, how fast the character moves over the terrain. To get that, we'll get the length of this new vector we just made. So from top view, the x and z coordinates are updating on the map, and we want to see how fast they're moving. And I suppose we could limit that speed if the speed is greater than 1f. We'll set the speed be 1f, in which case we'll want to go map the map velocity, not the hero velocity, dot normalize. That'll keep the direction of the vector, but it'll reduce it to a length of 1. So the velocity is only going to be 1. So now let's put that back into our original velocity thing. We'll get the x from that. And for the hero velocity z, we'll have to get it from the y component of the map velocity, because the map velocity only has an x and a y, and the z is actually stored in the y. If the speed is low, but still bigger than say 0.01, then what we'll do is we'll remember the last non-zero velocity, which will equal to the hero's velocity. As long as that speed's not 0, we can set it as a non-zero velocity, and so it'll remember that for next time. Now if it is 0, we're not going to use it in the calculation here. We're just going to use the last non-zero, and we'll say to angle in order to do a 2 angle on this last non-zero velocity, let's go over here to our extensions and our static class extensions, and we'll add an extension to allow us to just say 2 angle, and we'll calculate the angle from that velocity. Actually, you know what, in this case, it would make more sense to set the last non-zero velocity to the map velocity, right? Because we don't really care about the up and down angle. We just want to know which direction the character is facing relative to the map or the terrain. We'll have to change last non-zero velocity to a vector 2. Where is it? Up here? Let's make that into a vector 2. Last non-zero vel. So then here we'll have to fix this. Be 0 and -1. Oh yeah, this has to be 2. Okay, so back into extensions. Alright, so I just added this 2 angle code here. Oops, this is vector 2. Okay, let's change, oh, we gotta add this using, okay, and this is actually an X value and a Z value. And because of the coordinate system we're in, the direction that the Z value goes, I put a minus in front of this Y. That could be wrong, I might have to come back and fix it. But anyway, just imagine that this is a Z value here. So from the top view, X is like horizontal and Z is like vertical, if you were to graph it. So if you remember your trigonometry, tangent is opposite over adjacent. The opposite is the Z up-down value. Adjacent is the X horizontal value on the triangle. And if we get the arctangent, that'll give us the angle of that relationship. Okay, let's change this back to Y, go back to game 1. So hopefully here we now have the angle of the character. Most of this code that we've been doing so far has nothing to do with just loading the skin mesh and making it work. The only real thing we need for that is this, just to load it here, get the skinning tag, set the animation player, get the idle transforms right here, the absolute transforms for whatever animation it is, so whichever transforms. Get the animation clip, start the clip playing, and you can start and stop the clip too, depending on what's going on in your events in your update. So then in the update, we also update our animation player based on the elapsed time or some play speed that we've set up within elapsed time. And we get the collection of transforms for this frame, and we use them in our skinned effect in here. Now there's something that appears to be missing here. So we got our bone transforms for the current frame here, but I don't see us applying it into the effect. So let's go effect dot set bone transforms, and I'm gonna use bones 1. Okay, so I have no idea if any of this is going to work yet. Let's go to build. It might take a while the first time because there's a lot of data that isn't prepared yet, so let's have to be patient at first. 0, 0, so it should be good to try. We've got a problem here. File not found. Let's see what happened. Stuffy idle XNB. Oh, you know what? Never mind. It was no big deal. All it was I ended up changing the folder name. So let's try this again. Okay, for now I'm just gonna comment out this stuff too, just in case there's a bug. Hopefully I didn't forget anything here. Gather there's something wrong with our transformation here, the world transformation. So something to do with the hero position, or that, or matrix hero rotate. That doesn't exist yet, so it's probably all zeros, which is no good. So let's say hero or MTX matrix hero rotate is equal to matrix dot create from yaw pitch roll. Now, I believe yaw is left and right, pitch is up and down, and roll is around the z-axis. We'll go with the hero angle. We'll need to flip the character upside down. Well, the character is upside down. We got to flip the character right side up. So we'll make sure that 3.14 is on there. In your circumstance, depending on how your z-axis is set, you might not have to do that. And I'm going to subtract this 3.14 divided by 2 to get 90 degrees, because 3.14 is 180 degrees. So we'll do that to offset the angle so that the rotation angle is facing the direction we want it to based on the initial takeoff. Let's try that. So far so good. The player loads in idle animation and plays in idle animation. So let's go back up and we'll grab the other two. Since I did them exactly the same, I'm going to assume for now that they're going to work. And I'll just get the skin data from the skin tags here and put them in the animation players. And we'll allocate some memory for our walk transforms and run transforms. And we'll do one for blend transforms, so we can blend between these as the character picks up speed. We'll also copy our absolute transforms into those transform spaces we allocated, and we'll select and start the clips for the walk and run so they're all running together with idle. That way we can blend between the three as we need. Go down to update, and I'm fairly confident in this code so far. Might have to look at what I've done before just for a second to make sure I'm on the right track. I'll just pause it. Okay, for this bit of ground code here, let's grab that, move it underneath, and we'll set on ground to be true. Now the only thing is we don't want it doing this thing every single frame. So this is the one thing we don't want it to do. The velocity y 0, the velocity 0 and on ground true, we want to make sure that those are always going to be the case. But in this case we don't want it doing this because it'll make the character shake around, kind of jitter. Let's take this here and just say else. Here I'm going to say else if the hero's y velocity vel.y is less than 8f. That's really fast falling speed. I think we'll say 0.03f instead of 0.05. Alright, so this will accelerate the player to fall. This is the gravity speed here, or the gravity amount, so it's adding to the velocity with every frame. As long as the max gravity velocity is in reach, that's what that's for there. And it only does that if we haven't hit the ground. So that's why we got this else if here or there. Let's go ahead and make it so that the animation speed is going to match how fast the player is moving. So we've got this speed here from the velocity's length. We're going to multiply that by 6 to make it a little more potent. We're going to add 0.5, so there's sort of a minimal play speed. And let's make sure we're updating the animation for the other two that we're blending with as well. So technically, you know what, we probably could have got away with just making a run animation and just blending the idle animation with the run animation. But in this example, we'll go into how we can blend from one animation to another, and then to another. Let's change this. Instead of saying it's equal to that, I'm gonna have a couple of these so that I can blend animations between them. And we're gonna need the percentage between them for the interpolation. And so based on the speed, if we're approaching 20%, if we're somewhere under the 20% maximum speed that we're allowed, which is 1.0, let's say that bones 1 is idle anim player get transform, get skin transforms. And for bones 2, in this case, oops, what did I do there? We're going to use the walk anim player and get the skin transforms. And so the percentage in this case is calculated as 1f being 100% divided by 0.2f times. What that basically means is 20% is 100% of the animation blend. So once we reach 20% of the speed, we've blended 100% to the walk animation. And that's why I do this 1 divided by 0.2. That's 100% divided by 20%. So I'm trying to take the 20% and divide it up into units of 100, if that makes any sense. Okay, I probably explained that really badly, but so 1 divided by 0.2 times the speed, and that'll get us what percentage we are into that 0.2. So if it's a little confusing, just keep in mind that that's how that works. This is the first 20%. Now I'm going to say else. The else would mean that there's another 80% left to go, which is 0.8. So what we need to do is do the same thing we just did, except we're going to change what animations they are. So this one will be walk, and this one will be run. And the percent has to be calculated a bit different this time. It's going to be 1f divided by, we want to use a range of 0 to 80%, or 0.8, and it's going to be based on the speed minus 0.2f. So if the speed is 1.0, we want it to be 0.8 to get the true interpolation amount, because 0.8 is the full amount for this one. So this is the remaining 80%. And what I'm going to do here is go int equals 0 while I is less than bones 1. Doesn't matter which one you use. they're both the same length. Make sure we put in that I++, otherwise we'll have an infinite loop, and we'll say blend transforms I is equal to matrix, linear interpolation, LERP, bones 1 I, and bones 2 I, based on the %. Now here we're going to render the skin mesh. Now the first thing we're going to need to change here is this is going to be blend transforms instead of bones 1. And this will be also blend transforms. Okay, and everything else looks good. Alright, let's try out what we got so far. Invalid, this model does not contain a skin tag. Okay, I'm gonna have to check that out. Looks like, for some reason, this was not set to skinned model processor, which is weird, because I thought I did that already. Alright, everything's good. Okay, so we've got some animation blending going on. It'd be kind of cool if the camera followed them really good and if we had a shadow. Adding a drop shadow actually would be pretty easy. Do that next. We'll just do a basic ground drop shadow. Alright, so let's take a look at draw here. Before we draw the skin mesh, let's do some stuff with the lights here. We're going to need to set up for shadow. We'll do vector 3. We'll set an initial light position here just for now for demonstration. We can set up a point light source or some other kind of light source system when we do a skin mesh or a customized skin mesh of our own, which will be a shader that'll do the usual skin mesh stuff, but it'll add other features to our lighting abilities. Let's go float, light radius. We'll set it maybe to 80, and I'm going to say light radius squared is equal to light radius times light radius. It's basically when the light gets to light radius squared, it's going to be completely dark. So it's going to spread out quite a long ways in this case. It just depends on how you have your light shader working. We'll say light direction, or lit direction, is going to be from hero position, or from hero position minus light position. That'll get the direction of the light pointing at the hero. Let's get the distance intensity. A lot of this will just be stuff that'll be later useful in customized shader. The length squared. It's going to be comparing the length squared with the light direction. You'll see in a second here. So if the distance intensity is greater than the light radius squared, it's basically the character is too far from the light. We'll say distance intensity equals 0. Otherwise, let's calculate it as 1 minus, so we're going to invert this value, distance intensity divided by the light radius squared. Light radius squared here is going to be like the maximum distance that this light can affect anything. And distance intensity is how far the player is from the light. So if the player gets all the way to the edge of how far that light can reach, then this will be 100% value here, because these numbers will be the same. And then 1 minus 1 is essentially 0, so there's no intensity at that distance. But the shadow intensity is going to be stronger if the character is really close to the light, so wherever it casts the light on the ground will be a very sharp, strong shadow, because the character is blocking all the light. There's nothing really spreading. So at a close range, it'll throw a stronger shadow. In this case, I'm not sure if we're going to use these values just yet. I'm thinking because the different parts of the shadow will overlap, because we're not putting it on a render target. And like what I would do is I would actually put it on a render target, render it solid, and then re-render it with an alpha value that corresponds to the distance intensity. And we can do it just to try it out, but when we try it, I'll show you what I mean. Okay, so I just added this code here where we calculate a plane, and in this case the plane can span, the plane's kind of conceptual, it can span in any direction, any amount of distance, but we need to know the vector of what direction the face normal is pointing. In this case it's pointing up, and we need to know a distance along that vector that it exists at. So in this case it exists at the ground position. You can also construct a plane from vectors and floats too, for the A, B, C, and D of the plane, or from 3 points on a polygon, for example. Okay, so we're going to make a shadow transform matrix. And we just go matrix dot create shadow that's built into matrix, and we'll use the light direction as the first parameter. so vector 3 light direction, and we give it the plane to cast the shadow down onto. What that's essentially going to do is it's going to flatten out any geometry onto that plane, and we can take advantage of that to turn it into a shadow. Okay, so let's go down to our render skin mesh here, and right after we do the mesh draw, which is inside this effects loop, or yeah, just after the effects loop, it's inside the mesh loop. Let's add, after this, a draw shadow for each. In this case, it's going to be a fairly simple shadow. Let's say effect in mesh dot effects. We're just doing the same loop. It's on the same effect, so if you change anything, you got to change it back. So let's say vector 3 bold color is equal to whatever we had it set to. So if we decide to change the diffuse color at any time, we don't have to mess around with both of them. So diffuse color, we're going to set to vector 3.0. As far as the world transform goes, we're going to use that matrix we made. So we're going to times equals. So basically we're using this world transform here, and we're going times equals shadow transform. And that'll take the result and flatten it. And we'll go alpha is equal to 0. We could use this value up here, distance intensity. We could try that. And let's make sure we set the diffuse color back to old color. Okay, let's try it out. Oops, I think I had record turned off. Make sure you got this mesh draw in here, and then we can start it. Everything looks pretty good. And if we wanted, we could have a render target, like I said before, where we draw a shadow first before we draw anything else onto a render target. Then we draw everything else. Then we draw the shadow back into the scene before we draw the character. And when we draw the render target, we would use a shader that would blur the edges of the shadow and make it into a soft shadow. And it would also control the alpha intensity of it too, so if the character is really far from the light, the shadow would actually be quite a bit lighter. Maybe you'd have a minimum value of how light it can get. And if it's very close to light, it would be dark like this to show that there's a strong contrast between the character and the light source. I could adjust this distance thing. Now I don't want to change the light radius squared because we'll probably be sending it to a shader. We might, I'm not sure yet. Maybe not. We might calculate that on the shader too. So let's just try times 4 on this for the light radius squared and see what it does to the fade out of the shadow. That was unexpected. Yes, order of operations. Got to put brackets around this. Alright, let's try this again. 4. So it should fade out. It should go a little bit further before it fades out. Yeah, that's better. But I'm going to change it back to 0.9 and we'll just leave it at that. And for now, we're not actually using this stuff here. So let's just put comments over that so we know that none of that stuff's being used right now. But it's available to use for if and when we want to use it. If eventually we decide not to use it at all, we'll just get rid of it. Right, what's next? Camera. Let's make the camera controls a bit better. So we'll go over to the camera class, and what we'd like to do is set it up so we're taking advantage of this orbital camera stuff. So now we made it so that we can take the hero position, and let's just comment out this stuff. That's just for testing, and we'll shrink that. What we could do right from the get-go is go update target, have it point right at the character's position. So passing is hero underscore position. If we had a player class, then it would probably be hero.position, but we don't have that right now. It will not update. What's going on? Light direction does not exist. Oh, yeah, we need the light direction. So we're going to need the light position and the light direction. And then we'll try that. So now at least the camera kind of follows where the player is. What we'd like to do is have the camera kind of trail along behind the player. So if the player gets too far away, the camera starts trying to get a bit closer. Okay, so we're going to make a fairly advanced third-person camera system here. So we're going to say if target is equal to vector 3.0, we'll set the target equal to hero position. Now, We'll just put the target here. This way we can do other things to the target. So kind of like with the character control, we'll make a Gamepad left right rather than a move pad, and it'll get the Gamepad's thumbstick instead of the left one this time. Though we're going to use the right one. I guess it just depends on how you like your camera setup. It could be left or right. You could also make something to map out the controls and allow the user to just customize them the way they like them. Go thumbsticks right dot y. Oops. Now let's just get the forward vector here right away. This is the more so the desired direction we want a camera. It might not be the exact one yet. So the hero's position minus the camera's position. I'm just going to say float x1 is forward dot x, and I'm just kind of doing this to make it a little simpler. Y, Z, get up, down, look. So we're going to make it so that you can point the camera up and down, but also we'll make it so that I'm just going to do some simple stuff here. If position Y is greater than hero position Y minus, we'll say, the cam height offset. Let's just change that to cam height, make it a little bit shorter. It's still very clear what it means. And we'll reduce this to 20 because we're working with some smaller units here. And we're not going to want to do that. Target Y minus equals 10. We're not going to need that. So let's go down. Alright, so we used the thumbstick, or we captured the thumbstick controller, and for now we're just going to make sure that the camera position adjusts itself to try to get back into alignment, vertical alignment, where it should be. So if the camera was pushed up, it'll point down toward the player, looking at the player, and same if it was pushed down. And if the player ends up climbing something really high or falling somewhere far down, this will move the camera vertically to try to align with the player. And so if it's less than the desired Y position, we'll add 0.03. What we might actually want to do is use an interpolation value instead, but I'm just going to keep it simple for now. Let's go Gamepad up, down. That's what we're working on. And if it's greater than the dead zone, input.dead zone, you have to use the capital here, or it's because it's constant. That's why you got to do it like that. Gamepad up, down is less than negative input.dead zone. We'll go if, this is an awkward name, less than 0.0. Alright, so for that direction, position Y is greater than hero position Y minus cam height. Then we'll say position Y minus equals, I think here we'll go with some interpolation. So we'll take the Y position and how far away it is from the desired position, which is hero position dot Y. Technically it's hero position dot Y minus cam height. So it'll be itself minus the difference between where it is and where it's supposed to be in the vertical direction. But we don't want to subtract the entire distance. We only want to subtract about 10% per frame, so it kind of smoothly gets closer to where it should be. And that 10% is going to just be smaller and smaller as it gets really, really close to where it needs to be. And that's how it kind of drifts smoothly into where we want it. So let's just copy this, and we'll do it for greater. And then here, if it's less than, under the desired position. And let's just go position. Okay, I'm going to say plus equals position Y. So basically just doing the opposite. Okay, so let's take it for a spin and see what happens. It doesn't even compile. No. Let's see what happened here. Got a bug. Let's just take out this and this. We don't even need them. Up and down is not working. Okay, I changed this up quite a bit. So instead of what we were doing, let's get the camera back to a centered position. So it's vertically aligned with the camera, or I mean vertically aligned with the player. It's taking the camera position at minus equals the current difference between where the camera is and where the desired position is. And it's subtracting that difference, but only 2% of it each frame. And each frame it calculates a new difference and gets 2% of that, subtracts it, so that it gets closer and closer to its destination. It's sort of an ease-in technique. And here I set this target height to be this. So I'm not having to repeat it in big huge chunks here, and it makes a little more clear what's going on here. So the target height is the desired height that we want the camera. If position Y of the camera is greater than that height, which is quite a ways up. So if we adjust this value here to say 40, that's the camera position plus, or 40, minus 40, so it's 40 higher because of the way I have my Z, or my Y direction. As you can see, it only let the camera go so high if I do it that way. And if I want to go into, say, outer space, I could go like that. And this way you can see it from sort of a map view. So maybe I'll leave this around 100. This one's how far down you want the camera to be able to go. So if I said plus 200, I'd probably be able to go right underground. Except for when I did that here, this is all included to get our target height. So here we're going to have to go plus 200. And then that'll be the same as this. And that would essentially put the camera under the ground. Just going to leave it like that. You can try playing with these values here. Here we're adding 5% of the difference each frame. We could speed it up, so it's 25%. It would be almost instantaneous. Or we could slow it down. And we could speed up the camera retraction too. We could set this to say 6% each frame, and that'll bring the camera back to the home position really quickly. But if we do that, we gotta make this one bigger. Otherwise that one's gonna overwhelm it. So maybe we'll put this one up to 6. And actually I might leave them both at 6%. I kind of like that. So this new part, or this next part I'm going to add here is based on some older code that I did for another camera system. So I kind of already know what to do with this stuff. Alright, so angle velocity, if it's not 0, we got to make some changes. We'll say current angle is equal to math dot. Okay, let's make, we're gonna need some math. I'll borrow some math from the one that I made already. I guess what we should do here is, over on the right side, in Solution Explorer, we'll right click and add a folder. We'll call it math and collisions. So I'm gonna add a new class, and there's already like a math class and a math helper class. So I'm just going to call this math. Sounds like math. Since it's under this directory, it should be clear what this is actually supposed to be for. So I copied and pasted some constants in here from my old class. It's aligned by equals. A lot of these we probably won't use. We technically already have the math.pi, but just typing in pi is a little bit shorter, so I kind of like that. We'll probably use radians 1, radians 2. We might use radians 90 or radians 180. Half and quarter are essentially like half would be. Half is half of 1 degree. This is a quarter degree. Okay, that actually might come in handy. I just added this calculate 2D angle from 0, which again, actually we'll have to go over this math thing first and go using system. So again, this is one I copied from one of my old math ones. So what's going on here is we're using arctangent again to get an angle, and we're using epsilon, which is this tolerance value, to make sure that we don't have any divide by 0 errors here. So there's 4 different quadrants accounting for. I think the only reason I did that had something to do with these epsilons having to be different depending on which one they were in. Yeah, actually, I'm not quite sure why I did it this way. We could just do the usual 2-angle method, which should work fine. But not having a denominator of 0 is actually a really good idea here. And as far as this one goes, y less than epsilon, that's this. So I'm not too sure what that was for. For some reason, maybe I didn't want a 0 return. We might not even need that. I'm not really going to worry about it because we're not using this method very often. So let's put our math extension in here for setting a float to an angle. And again, this is copied from my other code, and this takes in a vector 2. So this is essentially the same thing as this. Here we're using the atan2, and I think that actually takes care of this stuff. for us. And that's the reason why we can get away with this. Again, I'm copying this from my other code. And this basically just loops the angle value so that it's always within this 360 degrees. And sometimes that can come in handy, especially if we're debugging. We want to know what angle it was at so that the value makes sense if you actually check it. And as you probably already know, 360 degrees is 2 pi. All right, so let's save this and we'll go back to game one. Actually, no, let's go back to the camera class. What we're going to do here, well, first of all, let's go up to the top of the class and add a math in here. A mad, sure, math. Okay, I'm going to take this out of the namespace for the math class, just so I don't have to keep adding the using for it. If this was a bigger project, I might actually do it the other way. Go back to camera again. And now, well, let's just do something simple here first. So, like we did this get up down look thing up here, let's do a rotate camera control, accelerate in a direction, To do that, we'll go to Gamepad, left right this time. It's greater than the input dead zone, or Gamepad left right is less than the negative input dead zone. We know that it's actually being pressed left or right, and it isn't just kind of close to the middle. We'll say if Gamepad left right is less than 0, and we'll change the angle velocity of the camera by, this might be a bit aggressive, but we'll go with radians 1. If the angle velocity is less than, say negative 2 math dot radians, maybe 2, angle velocity is equal to that maximum amount of change. So we get like a 1 frame of acceleration here. I don't even know if that's necessary. Let's maybe go half, radians half. This is analog, rotate, camera. If the Gamepad left right is greater than 0, we'll say angle velocity plus equals, well, let's just copy this and change the sign. Going the other direction, if this is greater than positive half radian, or no, positive 2 radians, then the maximum amount of angle velocity we're allowed to have is going to be 2 radians. Now, in game one, we're going to have an ambiguous thing come up here because we've got two angles now. We've got one in extensions also. So, because this one changes dy to a negative value. So I'm going to say 2 angle flip, or flip z, we'll say, because this is being used for x and z. Change that to 2 angle flip z. Let's see what we're getting so far. I forgot, we're not going to get anything yet because this changes the angle velocity. Now we're going to have to respond to the angle velocity here. So using that math class we created, let's go math.calculate, not math helper, math. Did we call it math or did we call it math? I think we called it math. Math.calculate 2D from 0, negative x1, negative z1. We need the forward angle of the vector, and we did something wrong here. Z1 is supposed to be this. I probably could just use these, it'd be a little bit more clear probably. So get angle, and current angle plus equals the angle velocity. So basically we got the angle of the forward vector of the camera. Now I'm going to go add additional angle velocity. We'll say current angle is equal to clamp angle, the current angle. Just makes it so that it's between 0 and 360. Technically, you can get away with going higher than 360 and just keep letting it go forever, and it'll keep giving you rotation, but I prefer not to do that. So let's go radius is float, math. This time we're using math, but we'll have to right click on this and say we're using system, and we'll get the square root, x1 times x1 plus z1 times z1. So basically that's like your vector.length method. We're just doing it directly here because we're using these here. Probably could have just used the forward. Oh, but then it would have to be a vector too. So we're just getting the length of the vector from top view. So just the x and z component. And we'll say position.x of the camera is going to be hero position.x plus a radius, so the distance away from the player. Essentially right now what we're doing is a transformation, almost like using a transformation matrix. And I'm going to have to cast a float because this will be double. We're going to get the cos of the current angle. So cos scales between -1 and +1, and sine will scale from -1 to +1, but I'm not sure which one it is again, but one of these starts at 0, one of these starts at 1. I believe it's sine that starts at 0, and then goes up to 1, and then down to -1. And cos starts at 1 and goes to -1, and then back to +1, passing through 0. So combining the two, if you had x is equal to cos angle, it would be 1 to the right, and y is equal to sine angle, depending on which direction your y is. But if it is sine angle, then it would be 0. And then as you go through the angle, as you keep increasing it from 0, and say you go up to 90 degrees, which would be half of pi, as you increase that number, the cos thing's gonna kind of accelerate towards 0, and y will kind of accelerate towards 1. And so what happens is you kind of get this arcing effect. And then sine will start to accelerate towards -1 as cos starts to accelerate, well, it is actually decelerating to -1. So then it goes, so what's happening is it's going around in a circle if you put the two together. So we'll say pose.z, because on the map it's z instead of y. So we're doing the same thing here, except we're using sine because we want this one to start from 0. Multiplying that 1 to -1 value by radius, you're just scaling it by the radius. And then you're adding this here, which is acting as your translation. And because of order of operations, this is happening first. So your rotation, which is the same with matrices. Your rotation comes first, which is right here. Then your scale, which is right here. And then because of order of operations, the translation is done last. So these will be calculated first, and then it'll be translated to where it needs to be. So you're putting the circle where you want it and scaled by radius. So what we're really doing here is, and remember these values here are extracted from this vector, which is the hero position minus the camera position. So we want to scale by the distance of those differences, and that's where we get the radius. So the angle amount that we want to rotate on that circle is put in here, and basically we just got the original forward vector, the angle that the camera's facing, and we added some acceleration to it, and now we're changing the position of the camera based on the angle, so we're making it rotate around the hero at that distance using that angle. We'll slow down the angle velocity by saying times equals 0.9f. So each frame, the angle velocity is going to try to reduce itself to be 90% of what it was in the last frame. Anything we do here, though, is going to counteract that. So any kind of input is going to be making this kind of negligible. But as soon as we let go of this, this is going to actually start to make a difference, and it's going to reduce the velocity of the camera rotation. Before we move on, though, this is going to throw a null because we didn't initialize it anywhere. So let's go up to construct, perhaps, and make sure to put in a math is equal to new math. So as we can see here, there's something clearly wrong with what our camera's doing. Oh, this should be an obvious bug here. This should not be positioned Y. That's why the camera went up high and it's acting strangely. Let's see if that's the only bug. We'll run it. Seems to work okay. Adjusted the hero height in game 1 to 1.5 and the ground Y to 0.8. Depending on the height of your character, you may need to play with those numbers so that your character's feet are touching the ground properly and so that your shadow shows up where you want it. So one thing we still want is sort of an auto zoom to go with the camera, so the camera kind of tags along with the player. To do that, let's first make sure, I don't want to calculate radius twice in case we actually did this, and we're going to definitely need the radius. So let's just grab this out of here. Since we know both these activities are going to need this radius. Alright, so we'll say unit direction, and as you probably already know, a unit vector is the same as a normalized vector. It's just a different word for it, meaning that it's 1 unit in length. So let's just get the forward vector first, and then we'll say unit direction dot normalize. And we'll need an adjustment. We'll call it 0.02f. And let's say our radius is really big, or the radius is a bit too close. And we'll say adjust equals 1, meaning the adjustment amount is going to be 100%. So it's way too far away, it's way too close, we need to adjust really quickly. 1.0 is 100%, that's the multiplier. let's adjust the actual position of the camera. Plus equals the unit direction, which is the direction between the camera and the player, scaled to 1 in length. And we'll multiply this by a scale amount, which is going to be our radius, minus 40 because we want it to be a certain distance from the player. So we don't want the actual radius. We want it to be, so this number is going to depend on what your preference is, how far you want the camera to always stay from the player. If you want it more, you'd increase this number. If you want it less, you'd make it smaller. So times just, and this is another percent multiplier. So this is just affecting how quickly it should try to make that change. We don't want the camera to get too far away, and we don't want it to get too close. So if it gets within those ranges here, again, it's just gonna really quickly adjust that camera. So we'll do the same thing with the Z value. Now, we could just say target is equal to hero position, but what I'd like to do is make everything happen really smooth. So let's make it so that the target's trying to approach where it wants to be at a certain speed, but it's not going to be instantaneous. And that way we get rid of any weird side effects or artifacts where the camera and the player suddenly move really quickly and you get this really jittery effect where it's really abrupt, like if the camera jumps or something, or if the player jumps or something like that. We'll have to do this on the basis of the X, Y, and Z because the Y will probably be a bit different. That's because of where the player's head is. And we kind of want to look towards the player's head mostly. So Y plus equals, basically this is a copy, except we're going to change this to Y. And I'm going to say minus 10 here, and then Y. So look closer towards the player's head, or rather than at the player's mid part of the player's body or feet or whatever. And we'll say Z minus target Z. Oops, times 0.1. So each frame is going to try to get 10% closer where it was trying to aim. Normally you'd want to aim right at the hero, but we're kind of keeping 10% of where the target used to be. Now, we don't have collision detection yet, so that'll be something we'll have to figure out. What I was thinking is, since most of this terrain in this area is going to be flat, I would make a separate collision detection system for these types of maps. And what I would do is I would just have a circle here, and just do a circle-to-circle collision detection and let the characters kind of slide around the edge of the tree. And if I hit the jump button, we'll fly to outer space, so that's something we're going to have to fix. We'll do that next. Oh yeah, we got one fatal flaw here in our update here. If the user presses jump, it could register that they push jump for more than one frame. So we're going to say if not on ground, or no, if it is on ground, then we'll accept that and set the change of velocity. And rather than minus equals 1.3, we should probably just set it to negative 1.3. We don't have a jump animation, so it looks a little strange when he's standing still and he jumps. If we're running though, it kind of looks okay. But I'd still probably want to blend with an actual jumping animation for when you're in the air. Looks like our shadow just goes on forever. If we had more geometry in here, though, it won't be a big deal. We could even set it so that the intensity of the shadow actually diminishes as it gets towards the edge of the world or something like that. I noticed the character's angles kind of slightly leaning to the left a bit, so it could be that the character angle in the animation is slightly off kilter. which probably shouldn't be too hard to fix. I think the camera rotation's a bit too quick. I'm gonna bring that down just a hair. Maybe we'll set this to quarter radians. So just a quarter of 1 radian, and maybe we'll just set this to a maximum of 1. If instead of doing this, that we actually took the analog amount and used that to control it. So let's copy this out of here, and we'll put it here, and we'll use some keyboard control, I think. So we'll say key down, keys.oem period. So the less than greater than symbols have the period and comma on the keyboard. And if it's the period, we'll rotate one way. If it's the comma, then we'll rotate the other way. Just make sure that works first. Just had to make sure my brackets were correct. Okay, keyboard control for that works okay. Okay, let's go down to camera zoom, and we'll put a constant float here. Distance from minimum distance from player. Now that's a lot of words, so min distance. We'll just say min distance, and just add a comment here from player. And we'll set this to be 50f instead of 40. So we'll say min dist and just insert that here instead. So I don't want the camera to be zoomed right up on the player all the time. It's a bit better. Yeah, that's a bit better. And it zooms in, it doesn't zoom in too close. Just depends on your preferences. Something like that, you could even make a settings option. Okay, so instead of this math.radians quarter that we were using for turning the camera left and right around the player to accelerate the camera basically, I'm changing it to Gamepad left right times 0.0038. And I was kind of playing around with it. I had the video paused for a second, and I was kind of playing around with it, and I kind of found that to be sort of a sweet spot right there. So sometimes you got to play with the numbers, see how fast the camera will move, see what we get. Except one has to be negative, one has to be positive. They're both moving in the same direction. So let's switch this one. Actually, I think, was that one supposed to be positive, this one negative? Oh yeah. We can use plus equals for both because, wait, minus equals for both. I'll try it out and see what that does. So I guess that would depend on how you want your controls configured. But minus equals for both is what we want, because the analog is negative if it's held left and positive if it's held right. And so that's why they're both minus equals, because one of these will be negative, one of these will be positive, depending on which direction you're pushing the Gamepad. I guess that's all I'm going to do in this tutorial. Turn the volume back up a bit, and I'm just going to play around with it for a bit and think of what else I might want to do. Could even make the character flip around in the air, or do if you go backwards in the button at the same time, maybe a backflip. It'd be a matter of adding an extra animation, or even just having the character rotate while in the air doing a regular jump. So you'd have to add extra rotation around the horizontal axis of the player. And you'll notice too, one of the nice things about this type of control scheme is you can just leave the character going forward and just adjust the camera itself, which is kind of like how it is in some RPGs like Dark Cloud. And it makes controlling the character's movement and camera very, very easy, very smooth. Well, hopefully that was helpful, and thanks for watching.